my comp just blue screened. So I'm back. Just going to open up Crayta. I was talking about, what was I talking about? I was talking about what we're going to do today. And I said, whilst Crayta's loading up, just, don't worry about that. It's loading up. It's on its way. Whilst that's loading up, what I was going to say is the first thing we talked about was, as a programmer, we first need to know what it is we are trying to make. We need to know where the goalposts are so that we can aim for that. It's pointless opening our programmer interface or IDE with not knowing where we're going to go or how we're going to know that we've succeeded. So firstly, what we're doing this week is we're going to make it so that when I interact with that pedestal, I essentially will open the door at the end of that thing. And then we're going to have a look at how do we make it so that there's a key and you can't, switch the pedestal without a key. And we're going to do that because that's going to use events, and that's something really, really powerful. Something else I'd quite like to dip into is conditionals. We'll see how far we get with that. So hopefully that was a useful and interesting recap in what we got up to last week. Let's just move our camera into the position, and there we are. So just back. Hopefully I'm back now. Fingers crossed. Cool. So interacting with the pedestal. So firstly, we have this switch pedestal, and what I did was, because I'm in advanced mode, so this is basic mode, and if I press tab I can go into advanced mode. And if I click on the switch, I can add a script to that switch, entity add script over here in the entity editor, and I can click new script if I want to create a new script, or I can add a script that already exists. And generally speaking, a good way to think about this is whatever you're trying to affect in the game, that's what needs to have the script on it. So if I'm trying to make this switch pedestal explode, that's where I need to have a script. What's interesting is the conundrum with, I want to interact with this, but I want to open this. So what has the script on it? The thing I interact with, or the thing that I want to affect when I interact with this? And so I think the clue is there's two different ways you can do it. And you can kind of choose which one you prefer. If we do it the original way, we can use this same method that we had before. So we've got rid of that property now, so that doesn't exist. So what we were doing was just making it explode. What we're going to do this time is open that door. So you might think, using the way we've done this before, the way we're going to open that door is by using this same function and somehow telling that door to open. And this is a good opportunity for our flowchart. So just to start with, let's go over here. Let's go on here. So remember when we said last time, if you are working on a problem, then it's a good idea to try and visualize that problem. So that's what we're going to do here. So there. It's like, hello technology. I can use technology, I promise. Okay, so let's visualize this problem. So we have our start point. And what we want to do is when we interact with switch, I'm going to shorten with to just W/. I hope that makes sense to everyone. So let's just draw a box around that. I use a box when it's just a process, and we'll get onto some other other shapes you can use in flowcharts. Yeah, I know there's a whole like flowchart language that you kind of have to get used to. When we interact with the switch, and then what happens? Think of this this flow line. It's called a flow line. Think of this as like an and then what happens? The player interacts with the switch, and then door opens. And we're writing this as a flowchart now because when we come to look at keys and stuff later, we'll be able to take this apart a little bit and see where that slots in visually. So once we've described our problem visually, so using a flowchart, we can then come along here and we can go, all right, which of these problems do I actually know how to solve? Do I know how to run some kind of functionality when someone interacts with a switch? Yes. So that should be the first thing that I tackle. The things that I don't know how to do can come after that, right? So this could be number 2. So generally speaking, when you come to a problem, once you've visualized it, like in a flowchart, it can really help you break down that problem into small steps. If you're still looking at it like, I don't even know how to start, break it down into even smaller steps. Make flowcharts within those flowcharts. Interact with a switch and break that down into a flowchart if you can, until you get to the point where you can start solving the problems. So problem number 1, interact with the switch. We know how to do that because we did it last time. Problem number 2, how do we open the door? We could make the door just disappear and remove collision. Like we technically could do that based on the code we looked at last time, which is a way of doing it. Should we start with that way? That seems like the most simplest, most straightforward solution to our problem here. So let's do that. So get rid of this code. Start from the beginning. Get rid of that. So we have a switch, pedestal, and it has one script on it. This explode me script. Actually, explode me doesn't make sense anymore. Let's just get rid of that script and add a new script. And this is going to be called open door script. Let's just call it door script. And then we could do things like closing the door. We're not forcing ourselves into a bucket of just opening doors. We are forcing ourselves into a bucket of opening and closing doors. I don't know why we're forcing ourselves into a bucket. Where did that come from? Let's just change this to on interact, because we know that any script that's attached to an entity that has the function on interact can get called by the API. Let's go over here. Let's click on that. Let's go to api.crayta.com, go to entity, and let's look for the script. Oh no, script actually, because we're in a script. Let's look for the entry points to our script. All of these things are events that Crayta triggers automatically, and it will call on those scripts on the thing that gets triggered. For example, you'll find on interact in here somewhere. Here, it's the first thing. So these are all different entry points that already exist. These are all things that Crayta will call without you having to define them. It will try and call on interact on every single script. It will, when a player interacts with this entity, it will try and call on collision when an entity collides with this entity. It will try and call on collision on every script attached to that entity. The same with all of these. And if a script doesn't have on interact, it won't throw any errors or get upset. It will just ignore it. It'll be like, oh, you don't care about on interact. Cool. I won't think about that. And that's the crux of events, and we'll get into that in a little bit. So we know that the on interact gets called when a player interacts with this mesh entity. And we also know that we can make things invisible and turn off collision by referencing the thing and then turning the things off. So if I want to affect this door using a script which is attached to this pedestal, this script which is attached to this pedestal needs a way to talk to the door. So this script attached to the pedestal needs a way to talk to the door. It needs to say, hey, open. Firstly, I need to introduce the two. It's very rude to just assume it knows who that is. So the way we do that is we give the script the opportunity to have a reference to the door. We give the script a reference to the door and we say name, and we do that in the properties here. Remember we talked about how a script can have a property, things that the script has that describe it. Things like health, and can be mantled. That's a property and a thing that we can affect. So the property we want here is the door that we want to affect. The type of entity that is, or the type of property that is an entity. So let's keep it like that for now. We've just created a property here. The name of the property is door, and the type of the property is entity. And this is how we do that. When I save this, notice there's a little asterisk that says you haven't saved this script. When I save it by pressing Control S, the asterisk disappears, and on our script we see that the door property appears over here. So if I click this drop down, it will list all of the different entities in my game world. So Crayta has automatically gone, oh, you mean an entity? Oh, I know all of the entities in your game. Here you go, have them. Have all of them. So if I wanted to, I could figure out what that door is called, Temple Door 1. I could go in this script and I can use this drop down to find Temple Door 1, which is there. And now door script knows that this exists. The door script that's attached to this pedestal knows that this door exists, and what's more, it can refer to that door with this property door, which means we can change things that happen with that door. So one thing we could do in our onInteract method is we can go self.properties.door, which is how we refer to this property up here. We go self.properties.door, and it's that. It's basically saying, get hold of that thing, whatever is in that door property up there. And we can go .visible equals false, and that will make that door invisible. Let's try it out. Let's just make sure that I'm not talking gobbledygook. So I'm going to walk up to the pedestal. I'm going to interact. Oh, door's disappeared. Hey, see you later, door. Okay, I'm great to just carry on and walk through it here. Oh no, I can't walk through here. Why not? Why can't I walk through there? Anyone know? I'll leave it a few seconds. My chat's disappeared again. I don't know where it's gone. So let me just load that. You've got it right. So we also need to, in our door script, do self.properties.door.collision. And I'm going to use the IntelliSense because I can't remember everything that the API has in it. Collision enabled equals false. So that should mean that the door's now invisible and I can walk through it. And if you wanted to, this is a totally legitimate way to make doors that you can open and close in your game. Ta-da! Okay, cool. Brilliant. So we've got that. We've basically done this. Tick and tick. Our work is complete, right? No, it's not complete because there is a better way, and there's nearly always a better way. And this leads me on to the main lesson for today, which is 1, make it work. 2, make it right. 3, make it fast. So this is like a 3-step process that I quite like. and I've read about it on dev blogs somewhere. Not sure who to attribute this to, but if you know, let me know. And the principle is, firstly, make the thing kind of, just try and get something working. If this is your first time programming, that would be get a console or a print statement printing out for yourself. If it's more like a visual language, like then maybe like draw something on the screen. I don't know, but make it work. Make it like possible that it's calling all the right functions, and print stuff out for yourself so that you know that it's working. Technically, this works. Then make it right. So make it work correctly, doing the thing you want it to do correctly. And that doesn't necessarily mean the most well optimized or the most beautiful code with the perfect programming pattern, whatever. It means make it right, as in technically this is accurate. So it's not only working, but it's working accurately. And then make it fast in that order. So make it optimize last. As you develop as a programmer, you're going to know how to write things more optimally. When you're sitting down to do number one, you're going to know, I could do it this way, but a more optimal path would be this. And your planning stage will be even more important at that point. But for now, while we're learning, firstly, make it kind of right. Secondly, make it actually right. And thirdly, optimize it, see if you can improve it. And that's not just make it faster, but also see if you can make the code layout nicer so that it's easier to understand. Decouple things so that you don't end up tying yourself in spaghetti knots. All of that stuff. So make it work, make it right, make it fast in that order. We've made it work, but we haven't made it right. Because right would be this door opening like a door, right? Doors don't just disappear. And that leads me on to this awesome part of today's stream, which is animation. And you'll see on many, many entities. Kazaki says, while in first person, is there a way to still see your hands and arms when sprinting, running, and seeing your legs when looking down? Russ says, no, not currently, but it's something we'd like to add one day. We hide the player model in first person for various technical reasons. There you go. So that's a discussion that's happening on YouTube. So there you go, Twitch people. Cool. So yeah, animation. So some things have animations already attached to them. This cage has some animations. This door has some animations. And if I hover over the copy animation names, it gives me the names of all of those animations. So we can actually open this door and make it look like it's opening all good and proper by using animation. And so we're going to do that now with this pedestal. So rather than making the door invisible and turning off collision, let's just comment that out for now. We're going to play some animations on the door. How, you may wonder, how do we do that? So here's a question for you who might be thinking, how do I do that? How might you find that out? How might you find out how to make animations play? What are our possible options with finding out things that we don't know how to do? One of them might be to ask on Discord. One of them might be to check the API docs. One of them might be to look at the tutorials, the YouTube tutorials, the written tutorials. See if we can find out how we might go about doing that. So I'm going to do the most straightforward, I think, in this instance is to go onto the API docs and maybe let's have a look for animation. Just search for that in here. And when I search, it comes up with 5 possible answers. The first one says animation handle. Not sure what that means. The second one says mesh. My door is a mesh, so this should be ringing some bells. And it says mesh, play, animation. So let's click on that. And it goes, there's 2 parts in here where it talks about it. But this example part down the bottom here tells you exactly how to play an animation on a mesh. It doesn't quite work in the context we're looking at. But if I go here, it's essentially this function call. So this API call that we can use. And it says play a named animation on this mesh once. And there's one below it, which has got the exact same function name. And this one says optionally looping. So I know that there's a couple of things I can do here. I can call play animation and give the animation name. I can call play animation, give the animation name and say true or false, whether it's looping or not. And I can do this, play animation, give the animation name and a whole bunch of other properties, including things like how fast I want to play the animation, whether it's looping, or I can even say I want the animation to last 3 seconds rather than specifying a speed. So that's a very powerful thing to do. So we're going to use just this first one. How do I call it? Well, this might seem odd. Let's copy that, take it over here and just put it in like this. We're going to just paste it in. It's saying there's an error because it doesn't actually logically make any sense to just put that in. But we'll break it down because we want to have a look at it on one line. So here I've pasted in the function from the API documentation. It says animation handle mesh play animation string animation name. So the actual function call is this part here. Just like we have colon and the name of our function here and those brackets, notice we've got colon, the name of the animation, and brackets. And in the brackets, it's got some words. And then there's this bit at the start. So this bit at the start is what's called a handle. So when we run this function, sometimes functions return things. For example, if I was to have a function that was multiply, so I said 2 multiply function and then put, I don't know, 4, it could return 2 multiplied by 4 as 8. So sometimes a function will perform all of the code execute all of the code that's within this function, and then it will give me something back at the end. And this is really useful for things like sounds, like saying play sound. It will give me a sound handle back at the end, which is my way of then being able to change that sound or stop it or restart it or whatever later on. So when I play an animation, it's going to give me a reference to that animation back at the end. I don't need to take it. I can if I want. It's there as an option. Let's have a look at what me calling this and taking that back would look like. So I could do local. Actually, that needs a whole load of stuff. So what I'm actually going to do, let's just have a look at a simple example of playing an animation. So self.properties door was our way of referencing this door. I want to call this play animation function. So I'm going to do the same as what this thing does here. Colon play animation. And notice that IntelliSense is telling me how to finish that off. So it's coming up and it's saying exactly what it said in the API. So if you weren't sure and you just started typing play, then this would come up and you could always run with that. So play animation and open bracket, just like this here. So I'm basically copying from this point onwards, colon onwards, string animation name. So a string is in quote marks characters. This here is a string, as is this here. So a string has got quote marks surrounding it, and it can be alphanumeric characters in between those quote marks. Alphanumeric just means alphabetical and numerical characters. Now, what word might I want to put in there? So I've got self.properties door, which is my reference to the door. I've got colon play animation. So I want to play an animation, and the name of the animation I want to play needs to be in quote marks because it's a string, and there needs to be an end bracket. So I'm just going to comment that out for now so it's not distracting us. This is the line of code we're interested in, and the name of the animation I want to play. Let's go and get that. So I'm going to click on the door, I'm going to hover, copy animation names, and there's all the different animations I could play on that door. Closed, closing, closing slow, open, opening, opening slow. So let's just pick one of those at random. Let's pick opening slow. I'm not picking that at random. I know that that's the one we're going to use. The one that I think we should use is opening slow, and I need to copy it exactly. Notice it's opening underscore slow. So I've copied opening underscore slow. If you're not sure what it is, you can always click the copy animation names button, paste Control V or right click paste those in here, and then take which one you want and paste it in the play animation in between the brackets. So now we've got this door and we're asking it to play animation, and the name of the animation is opening slow. This bit here in between the brackets is an argument. We're sending an argument into this function. We're basically giving it some data in the hope that it does something with that data. And you'll see lots of functions do this. You send in some kind of data in order for it to manipulate that data or use it or change what the function does in some way according to what you're sending it. So let's run this now. Press F5 and go and have a look. We're going to interact with this switch and the door opens. But now it opens like a proper door rather than just making this whole thing disappear. And what happens when I walk through it? No collision. So we know we're doing something right when we're having less lines of code, and also when it looks better and feels better. So we've opened our door there instead of just making it disappear. Now, making things disappear is just as valid, especially if it wasn't intended to be a door and you've turned it into a door. I don't know, by using an air conditioning unit. It's always the aircon unit with me. Why is that? I don't know. So we can make our door invisible, or we can use animations if it's one of the proper doors. And if you want to know what meshes can be animated, a handy thing to know is that you can click on this little drop down arrow next to tags and click animated, and this is all the animated meshes. There you go. So now you can go away and explore those and turn them all into doors, or just use them as they're intended. Either way. So that's animated meshes, and that's how we can open our door by using an API call and a reference to the door. Are there any questions? I'm just gonna Cool, I'm back. I just had to get the, yeah. Anyway, if you've got any questions, don't hesitate to let me know. So we've got a door and we're opening it. What would be great is to have a sound that goes along with that, right? Right. So along with playing our, don't worry, Silex, I'm back. Along with playing our animation, we can play a sound. And this is another really fun API call that I wanted to introduce today, is playing a sound. So last time, the way we did it, well, we did it the same way. So let's have a look at how we did it last time. We essentially need to play a sound on the entity we have at the moment. But rather than playing the sound on our switch pedestal, because that wouldn't make any sense spatially, if our switch is making the sound of a great door opening, and then we're over standing here and we're like, but the sound is coming from the switch, which is super weird because the sound should be coming from the friction between all the massive granite slabs here. So rather than us playing the sound on self get entity on this thing, we should be playing the sound of the great door opening on the door. So let's do that. So the way we're going to do that is we're going to add a property for the sound asset. And then we're going to play that sound when we interact. Should we update our... Yeah, let's update this. This needs updating now. Let's keep on top of that. So play opening sound. That's the next process. So let's do that in a little process box. And let's go back into our code and let's add that. Yeah, self.properties.door, and it needs to play a sound. So one way I could find out how to play a sound if I'd forgotten was to go to the API docs and look for entity and how to play a sound. Another way is for me to go, I remember it started with play sound. So play sound is what we're going to use, and let's just hover over it and we see that we need a sound asset and it says number fade in, but we can just use a sound asset and it will play it all with the default stuff. So let's just click that, play sound, it will pre-fill for us, and the sound we want to play needs to go in here, in between there. That's the argument we're going to put in here. So the sound asset, we need a property for that. So we can go up here, let's make ourselves a property for that sound. Door opening sound is what I will call this. And the type is sound asset, all one word, all lowercase. Save it, so the asterisk disappears, and we get our new box down here. If I click on that drop down, it has all of the sounds. Let's go over here because I prefer navigating this menu, and I'm going to look for this. Or that's a boulder rumble. It could be that kind of door sound or that kind of door sound. There's lots of different door opening sounds. But I want to go for that boulder rumble. So let's put that in there. And now this door opening sound property knows about the boulder rumbling sound. But this property here contains that rumbling sound. So imagine that this property is a little shoebox, and in that shoebox we've put a boulder rumbling sound, and we want to use that here because we want that to be the sound that plays when the door opens. So just like I referenced the door, self.properties.door, which referenced this property here, I can reference this property here by doing self.properties.door opening sound. So now when I press F5, I've saved it. When I press F5, let me have a sip. I can walk up to my switch, interact with the switch, and it plays the sound and opens the door. But notice the sound continues. It's a looping sound. It says boulder rumble loop. And so that's not desired behavior. Remember, we're still at make it work for this bit. We're not make it right yet. We're going to do make it right now. So do you remember me saying, oh, it's going to return this animation handle when we use this function? And I was like, don't worry too much about it. Well, for this sound, we do need to worry about it because we want to stop it. So we're going to do local, and we're going to stop it. So we're going to do local door opening sound, or we could just do open sound ref equals. So now, oh, whoa, what's happened here? So this part here is still going to do exactly what it did before. Nothing in that part has changed. What I have done though is because I know play sound. If we look at this documentation here, it says sound handle. Sound handle is returned when I run the play sound function. That means a reference to the playing sound is going to be given to anything on the left-hand side of this equals. So for me, I've created a variable that's going to store a reference to that sound that is currently playing. So that sound is looping away, and now I can refer to that sound. I've got a reference to that sound that's currently playing. This local keyword is a Lua way of saying make a variable, which is just like a property. It's a way of storing data. But the local means I only care about this particular variable until the next end. So when Lua hits end, this open sound ref just gets like deleted, or it doesn't care. So the reference to that sound will be essentially ignored after that point, and it will pretend it doesn't know what you're talking about whenever you try and reference it after that end. So what we need to do is basically we've got hold of the sound that's playing, and we want to stop it after a certain amount of time. Whew. So how are we doing? We've got hold of a sound, a reference to a playing sound. We've looked at how to play a sound. We've looked at how to play an animation. The next thing we need to look at is how to stop playing that sound. Let's go back to our flowchart. And let's draw the next part, which is stop opening sound. That's the next process we need to do. So we've got play opening sound, we've got stop opening sound. Let's not forget to enjoy the success of our accomplishments. This was part 3, and we did it. We played that sound. This is part 4. So part 3 was something we didn't know how to do. We worked out how to do it, and then we did it. Tick. Part 4, stop the opening sound. And we want it to stop when the door closes, right? So part 4 is something we don't know how to do. We're going to have to work out how to do it, and then we're going to do it, and then we're going to give ourselves a nice big tick to say, well done us. Let's go and have a look at this sound, play sound. In fact, if I scroll down here, play timeline, nope. So we've got this play sound, which is what we've done. And we've also got stop sound, which takes a sound handle as its argument. So we know we can stop the sound eventually. What we need to do ourselves is figure out how to stop it. But firstly, let's just put that in. So let's put self.properties.door stop sound. And let's put in our open sound ref. So we're going to play the sound and then we're going to immediately stop it. Let's see what happens. So I should walk up to this pedestal, interact with the pedestal. So that hasn't quite had the desired effect. And it might be because it's happening immediately after playing it and it's not giving it time to, let's just see if there's any errors. Right? It's not giving it time to start playing before immediately trying to stop it. And we also want to stop it after maybe a second or so. So this brings me on to a nice point to talk about, which is our schedules. So if you want something to happen in a predetermined time in the future, you can use something in Crayta called schedule. And let's have a look. It's in the script functions in here. Let's look for schedule. Here we are. We can do this. We take a script. We can run a function on that script, and we can run a function called schedule, and we can run some code within that schedule. So rather than stopping the sound immediately, which wasn't going to work anyway, let's stop it after a second by using a schedule. So in order to use a schedule, let's grab this line of code like we did before. We'll just copy that and paste it in here. And it says we're going to return a schedule handle. Just ignore that for now. Script component. What's a script component? This is our script component. Remember at the start I said that scripts, another name for these scripts is a component, because we're using an entity component system and all of that stuff. And each entity has components. This entity has a mesh component, and it also has this door script component. And the door script is a script component, this thing. So how do I refer to the door script? That I do simply with self. That's referring to the door script component. Self, and I can schedule, and then I can create a function in here, function, like this, with an end. So this is making just an arbitrary function that I'm not going to call again. That's why I've not got, you know, like the name of the thing I'm talking about or anything like that. I'm just making a function that will be called at some point. And when I'm using a schedule, the reason I'm using a schedule is because I can do wait and give it a number of seconds. It's an immensely powerful thing to learn about and to use in your code. Is almost like a timed delay before doing this line of code. So one of the things I wanted to talk about today was using schedules. Let's see how we can use schedules and delay some code from being run for however long we want it to run. Notice though that the code after the schedule, after this end bracket here, this will carry on as if it's run straight from there. This is just saying this bit of code here is diverging. It's going to run in a separate place. So here is where we will put our stop sound. So wait 1 second and then stop that sound. Ta-da! There we go. And if I press interact multiple times, it's playing that sound for 1 second and then it's stopping it. Maybe the timing's not quite right. Maybe it could be a little bit longer. You know, make it work. And now we're making it right. So has anyone got any questions about schedules? Now it ends a bit abruptly, so we can double that up a little bit. Maybe we want to put a big bang. Oh, not bang. Let's look for some kind of impact. While I'm doing that, let's look for... That's quite nice. There you go. Something like that. So we will have door opening sound, name equals door bang, door impact sound. This type is a sound asset. And hopefully you're running ahead and you're able to think, oh, how is he going to call that function? Well, how's he going to play that sound? Well, I've added this property up here. And I'm going to play the sound the same time I stop this other sound. And I'm going to just do it exactly the same way I did this. So I'm going to copy that line of code, paste it in there, and change door opening sound to door impact sound here. So now, wait 1.2 seconds while we're playing that rumbly sound. Then stop the rumbly sound and play the sound of a big bang that the door has finished opening. Let's just make sure we've got that big bang. Oh, I prefer the gong. Okay, cool. So let's try that. So schedules, I'm just going to open the chat again, schedules. And if you've got any questions about schedules, okay, so Naya Alchemy says, yay, I didn't miss the whole stream. Hello, Naya Alchemy, good to see you. You can, of course, catch up on this stream. It'll stay on YouTube and Twitch for a bit. Oh, Silix, can we use schedule on the tick? I would probably avoid using schedule on tick. I would prefer, it would be better to use it in an event or something like that, just because if you start using it on tick and then you start building up lots and lots of schedules, like every time, 60 times a second that tick runs. So if you're on 60 hertz, so that could end up very messy and lots of overheads. So I would just suggest you use it in like one-off situations to start with until you've got your head around it a little bit more. Okay, so we've got our schedule, and now we have our stop sound, which is going to stop that sound. Let's go back to this. We have play opening play opening sound, play stops, stop opening sound. And let's go back to our red pen. Next thing we did was play door impact sound. Okay, whoa, we have done loads. And let's not forget big ticks. Hey, we've done them. We've done those things. Maybe even comment to ourselves here. Required a schedule for delayed call. Oh, I've used the flow line by accident. Oh no, now I've erased it. Where's the thing? B. Let's just rub that out. Let's make that a comment. There was a slight issue at the start, so the beginning was chopped off, but we'll see what we can do to recover it all. Yeah, thanks, Russ. There was a blue screen moment. Not entirely sure what happened there. Never happened on this PC before. So I was as shocked as you. It was not planned. Okay, so let's try out our newfangled door script, which is going to have some cool effects, cool sounds even. So let's walk up to the pedestal. There you go. I mean, it's a bit cartoony with that gong. It probably would have been better with the horror hit. Let's do that. Because it's like it's a horror hit, isn't it? Let's see if that's got a better feel to it. This is, I'm drifting off from scripting now, and this is way more like experiential design, game design stuff. Yeah, it's got a definite awful, scary vibe to it, which is great. It's exactly what I want from my door. Okay, any questions about what I'm doing at the moment are more than welcome. I feel like we've accomplished quite a lot already. We've looked at how to play an animation, which was that API call there. We've looked at how to play a sound, which was that API call there. Then we said, our sound's looping. How do we stop that sound? The way we do that is we get hold of a reference to that sound that's currently playing by simply putting this part before we run the play in front of this play sound function call. So we have this play sound function call, which will go and play that sound, and then it will return some kind of reference to the sound that is playing from that. It will return it, which means that we can put an equals before that function call, and any variable on the left-hand side will then capture that reference to the playing sound. So open sound ref here is basically a reference to the sound that's playing. So the sound is looping over and over again, and this thing is like a shoebox that has that sound in it. It's caring for it like this. Then we looked at how to schedule a function. A schedule is our way of delaying the call of something. So we're basically saying wait 1.2 seconds before stopping that sound. And we use schedules as kind of timers a lot in our Lua script, but really what that's doing is it's saying run this off the main thread. And there's a lot of stuff to do with threading that you we will look at in the future to do with race conditions and optimization and all of that sort of stuff. But for now, we're just using it to stop this sound and to play another sound when we stop that sound. This one is a one-hit sound, so we don't really have to worry about trying to stop it in the future. We're just going to play it, and that sound is that door impact sound. I've just gone over that again, just for anyone else that's joining, and also for a bit of a recap for all of us. And now to test it, interact with the pedestal, door opens, the sound plays, the sound stops, the other sound plays. Cool. Right. Any questions? All welcome. So the other thing I was going to look at, so we talked about arguments, and that was one of the main things I wanted to talk about today. And we've also talked about return statements, which is where we can capture the thing like this. Another thing we wanted to look at was events. And it's another extraordinarily powerful concept in Crayta. So what's an event? Well, technically, this is sort of an event. An event is anything that happens in your game. Anything that's measurable or quantifiable in some way. So an on-interact would be an event. A player interacts with something and the creator goes, there's been an interaction. Fire an event to everything that cares about that on-interact event. And that's when this function gets called. And there's lots of different events. And we looked at some of them when we looked at the script entry points. These are all events, all of these things. But we can also make our own, which is even cooler. We're going to make an event when we're going to change this door script. Remember when I said the thing that is being affected should have the script on it? Well, so far we've affected the door. We've affected just the door, but we've been using this pedestal to reference that door. And that's not ideal, because what if there's another pedestal over there that also opens that door? What if I can open that door by walking into a certain area? What if I want to be able to open that door from lots of different ways? So that's where the code we've written, whilst it works, it's not optimal, because it only works on this one thing, right? So what we need to do is we need to move our door script onto the door. And then we need to call all of this functionality when we interact with this pedestal, instead of like using this script entry point here. We need this pedestal to tell the door to do the thing. And then we can, take that functionality off, we can change it, we can do other things, blah, 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 blah. So the way we're going to do this is, okay, I've realized there's an issue with the code. The issue is I don't want the door to be controlled just by this pedestal. I want the door to also be controlled by anything else I want. So we're going to take the door, click on the door, going to do entity, add script, and we're going to add our door script to the door. I'm just going to move those properties over. So we won't necessarily need our actual door reference, because that is itself. But we do want to keep hold of the names of these opening and impact sounds that we worked so hard to find. So I'm just going to add those. Had our boulder rumble loop, and we had our horror low hit 1. So those two are exactly the same as those two. We're going to change this door script now so that it's no longer the pedestal in the frame of the pedestal. It's now going to be in the frame of the door. So be gone from the pedestal. Functionality just gone. I clicked the little cross in the right corner to remove that script from the pedestal, and I've added it to the door. So now, technically, this won't work. Let's see what happens if I just run that. You could probably guess, but I want you to maybe think about what might happen. Let's perform an experiment. Hypothesize. What's going to happen when I interact with this pedestal? What's going to happen when I interact with the door? Let's try it out. Interact with the pedestal. Nothing happens. Not even an error. Interact with the door. Nothing happens. An error. Door script 14, attempt to index field door. So door script 14, this bit here, that is saying there's an error on line 14 of our code, which is this bit here. And the error is attempt to index field door, a nil value. What that is saying is door is nil. We don't know what door is at this point in our script. And if we look, let's go to the door. If we look, that's because we haven't put door, any kind of door in here. So it's saying, hey, I don't know what door is. You didn't tell me. And so, of course, there's an error. But we're not actually going to ever give it that door. We're going to delete that. So now this property doesn't even exist. Not that it's nil, it just doesn't exist. So instead of self.properties.door, which was our way of doing it with our pedestal, let's do self get entity, which is a function. That's why we're using colon here. And that's why we have the brackets here, open and close brackets here. Get entity is a function, and it's a function which returns the entity that this script is attached to. Let me say that again. So this script is on the door. To get hold of the door that it's on, we need to do self get entity, which returns that door. And rather than storing it in a local variable like we did with this bit, because we're not going to use it later, we're just going to literally use it on the same line. We're gonna keep it on the same line here. I could, if I wanted to, do local door ref equals self get entity, and then take door ref and run the function on that. I could do that if I wanted to. But this adds a lot of extra code to maintain, and it's not as readable for us programmers as self get entity play animation. And so wherever I've got self.properties.door, instead of having self.properties.door, I'm going to change that to self get entity, because now this script is on the door. And so I can get hold of the door more simply than trying to refer to it through properties. Hopefully that makes sense. I'm just going to change self.properties.door to self get entity. And now the thing that we're affecting, which is that door, can open itself quite happily. Let's see whether that works. So notice that the script is still using onInteract. And so technically, when we interact with the door, the code should run. Let's go and do that. Interact with the door. And now it opens. Okay, so we've changed the context of the script. The script is no longer on the pedestal, it's now on the door, which meant we need to remove the door property because we don't need it. And instead we use self get entity, and it works just fine. Except now we interact with the door and it opens. The pedestal is redundant. What we wanted was to interact with the pedestal and the door opens. Which brings me on to back to the events that we were talking about. So rather than onInteract, which was our trusted entry point to this chunk of code we were writing, this was our function name, I'm going to make my own function name. I'm going to define my own function name, and this is going to be called open door. And this is all the code that we need to open the door. Let's clear it up a little bit. Let's get rid of some of this stuff. So this is all the code we need to open the door. This was the door animation. This was the door opening sound. This was the schedule, which then stopped the door opening sound and played an impact sound of, like, you know, the door things finding their home at the end. So we've got open door. Now, if I run the game again, let's run the game. I've changed that function name, so it's not onInteract anymore. So now when I interact with the door, nothing happens. When I interact with the pedestal, nothing happens. So now there's a chunk of code, there's a function sitting there called open door, which doesn't get called ever, but it's got everything that it needs to open the door. To call that function, I need to use an event. So an event is something that happens in the game, and there are some events which are already set up to be able for you to call functions in scripts. One of them is this here. You see we've got onInteract in our entity editor. So I click on the pedestal And I've got this on interact, and next to it is a little plus. If I hover that, it says new binding. So on interact is an event, and when that event occurs, when the player interacts, I can actually add things that will listen out for that event. And when it occurs, functionality gets executed. So what I want is to reference the temple door. So I clicked plus. I need to choose an entity. I need to choose the script that is on that entity, and then I need to choose the function that is in that script to call when a player interacts with this switch pedestal. So let's do that. I can do that in two ways. Firstly, we need to do the entity. And now I could use this drop down, or I can click and drag onto there. Let go. And script gets populated already. Notice door script's already appeared. And that's because if we look at temple door, that's the only script that's on temple door. So when we interact with this pedestal, it's going to, hey, temple door, you know you have that door script. I want you to run a function in that door script. And the function I want you to run, there's only one function in there, and it's the open door function. And once all of those are filled, all the red exclamation marks and the scary stuff disappears. And now this has got a binding to temple door 1 door script open door. So now when I interact with the pedestal, I should be able to open the door. Ta-da! Hooray! So we made it work, and now we've made it right. And sort of made it fast, because now if I want to, I could remove it from here. Hey, this looks like a really logical place to open the door. Let's just remove that. And instead, let's make it so when we interact with this pillar, we open the temple door. We're going to drag temple door on there. Door script already selected, and open door. So now, oh, this looks like where I need to press. Oh, weird. That's not working. What about this pillar? I've made a puzzle game. There you go. Job done. Puzzle game complete. It's not that easy. I mean, it technically is. That's essentially like the crux of events, and they're super powerful. So we've got the door now is able to be opened over here. What if I did on collision? And so instead of using the on interact on the switch pedestal, it's a collidable thing. So let's get our temple door and run this when we collide with it. So we've got on collision now. Let's see if this works. I'm tested. There you go. So now I run into the pedestal. Or jump on it. Jump on the pedestal. And so now we've got an on collision event instead of an on interact event. What about, here's a fun thing we could try. Let's get a beach ball. Let's get the old beach ball here. And we're just going to plop that there, and we're going to turn physics on. We're going to override the mass and make it like, I don't know, 1 kilo, which is actually really heavy for a beach ball, but you know, it means we'll be able to knock it about a bit. So what if I try and knock the beach ball into there? Oh, knocked it backwards. Go on, football. Come on then. Hey! So that's an interesting thing. We can now maybe play a physics game where we knock beach balls into things and they run events when things collide with them. Let's just make sure it was that and not just me accidentally hitting it. So walk up to the beach ball. Okay. Some of my physics is a bit dodgy here. It's probably the weight of the beach ball that I added. There we go. So now it's rolling down the steps. I didn't make it. Come on. Oh, it's gone. alternative option. Let's move it over the pedestal and drop it from really high. I just want to see whether colliding with it using a beach ball. No. Okay, so it's just when humans collide. Yeah. Just wanted to see whether we could make a physics puzzler out of that, but not so. Yeah. So we have on collision events, other things we could do. On destroy, maybe you have to destroy the thing. You know, damage it with whatever, TNT, and then the door opens. You know, you can use any of these events to do that stuff. We had interacting with this thing to open the door, so that's a cool event too. We use that to make some kind of puzzler. Let's return the puzzle to its original puzzly, slightly less puzzly thing. Incidentally, if I made that as the entry point, there's nothing pointing to it to suggest that that is the entry point. So essentially what I've made is like one of them pixel hunter point and click games, which, if you know what I mean, incredibly complicated, but not necessarily the good kind, because you're just hiding things from the player and not actually giving them a chance, which could be frustrating. So probably bad game design, just randomly doing that. Let's keep the beach ball. So now we've got interacting with the pedestal opens the door. The last thing I wanted to look at was how do we make our own event so that when we, I don't know, pick up some keys or pull a lever, it unlocks the door, and then we can open it with the pedestal. Cool. So I've had a question. Well, it's more of a statement. I would use a statue for the hidden door open like seen in some movies. Yeah, that's a really cool idea. You should definitely do that. Hopefully you'll know how to do that now that we've been through this. So what I wanted to do next, and we're just going to look at the time, 5:33. Okay, so have we got time to do this? Let's see. Probably some part of it. Let's make the door locked, and then make it so that you have to pull a lever to unlock it and then press this pedestal. So this is where we can talk about our conditionals. And I think half an hour is an amount of time we can use to talk about conditional statements. Firstly, let's set up our game so that we can do this. So back to the problem, we need to identify what we're going to make before we code anything and know what it looks like at the end so that we know when we've hit those goalposts. So what I want to do is I want to have a lever that will unlock the door. So the door needs to have locked and unlocked, two possible states, and we'll talk about states a bit more detail in the next stream. When we pull the lever, it unlocks the door, and when we click on the pedestal, it opens the door. So we can do a lot with sound in this. So what we're going to do is, unlock the door and then open the door. Where would we put the lever? Let's just look for our levers. Lever, and let's put a lever here. It's near enough to the door to show you that it's got something to do with the door. But what's going to happen is maybe the person goes, oh, that's to open the door. And then they try it and it doesn't open immediately. Or maybe they try this first. The player tries this first. And so we need some kind of reaction to show the player that this is interactable. Because if they try it and it does nothing, then they won't probably try it again. And we need some kind of way of showing that this has done something. So both of these things need to do things. and then the door needs to open. So the door needs, yeah. Okay, cool. So at the moment we interact with that and the door opens. Let's make it so when you interact with that, it's locked and it sounds locked. So to do that, let's just use a block comment using dash dash square square bracket and a n square dash dash to end it. So this is a block comment, which means comment out everything after that until you reach one of those. They're really helpful for like commenting out chunks of code all at once, because what we want to do is rather than open the door, we want the sound of like a door that's locked. So let's look for locked. They're all music. What I want is some kind of, yeah. Let's just use a generic. Don't use that. Let's just use a generic locked door sound for now. So we're going to just play our locked door sound. Let's go name equals locked door sound. So we need a property. When we want to play a sound, we need a property of that sound, which is going to refer to that sound asset. So let's create a property for that sound asset, which we can see once we've saved it. Control S, we can see that we've got this locked door thing down here, this locked door property. And now let's drag on our locked door sound. When we try and open the door, self get entity. Ooh, get entity. Play sound. Self.properties.locked door sound. So basically the same as this line of code here where we played our door impact sound, but now we're playing our locked door sound. So let's give that a go. So I'm going to press F5 to test it. I'm going to walk up to the pedestal, interact with it, and it makes a sound which shows the player that it's interactable, but it makes like a deny sound, which shows that it's interactable, but something is amiss. It's not quite doing what it should. I'm just going to get rid of the beach ball as well, because that's not doing great. And then the other thing we need to do is give this some functionality of unlock door, which, so this lever, when we interact with it, it needs to, and what's cool about this is it's got an animation. It needs to play the animation of the lever being activated, and it also needs to tell the door to unlock, doesn't it? So let's add a lever script here to firstly play the animation and play a sound for this lever. So when, let's just do activate. Rather than doing on interact in here, I'm going to use activate, and then I'm going to hook up my binding on the on interact event the same way I did before, which means that because I've not called it on interact, it means that I can call it from other things and it doesn't necessarily get called. You know, I can make it, turn it on and off the on interact binding here. So here, when we activate it, we want to do self get entity, because this script is attached to this lever, and we want to do that thing again, play animation. Remember, we looked at this earlier. Let's look at the animation names. We've got deactivate, activate, active, and deactivate. The animation I want to play is activate, because there's multiple. How do I know that not to use active and to use activate? Well, activate is a doing word, so that implies that the lever is going to move. Active is just the state of the lever, so that will automatically set it to be active. And deactive, the same thing. So actually what I probably want to do in my lever script is use the init function, which is a entry point to our script. It's called once at the beginning. We looked at this last time. And I want the lever to start in a deactive state. Deactive. Which if we look at the animation names, we've got deactive there. So we're going to start the lever deactive. When the user interacts with it, I want to call this function activate, and that will set the lever to play the activate animation. So with the lever selected, I'm going to click on interact, and I'm going to set the lever to bind to itself to lever script, and I'm going to call this activate function here. Whilst we're here, let's also add a reference to a sound. Activate sound. Type is sound asset. And in here, self get entity play sound. Self.properties.activate sound. Notice that I'm using just the same API calls again and again and again. Just animation, play sound, play animation and play sound. And by using just those two, we can make some pretty complex behaviors in our game without even touching conditionals, which we will do in a couple of minutes. So I need to just get my little lever sound switch. Let's look for... Ooh. That's got such a satisfying switch sound. That's too much. We're not in steampunk land. It's too small. I mean, it says space props, but I quite like that. There's so many switch sounds. It's great. I can even use that. I liked this one. It's subtle, but it's enough for me. Okay, so play that sound, play that animation. Just do that for now, and notice we've bound it to our onInteract event. So let's go up to our lever. Remember we have this pedestal, which now makes the sound of a locked door. Let's go to our lever. That switch sounds very satisfying. And what we want to do now is this should now open the door, right? So the last bit, the last piece of the puzzle here is our conditional statement. A conditional statement is where logic branches. So we're looking at this flowchart here, and rather than interact with switch just being the de facto it works situation, let's just use our marquee tool here and just chop that. Let's bring that with us. Sure, actually, let's not bring that with us. Let's leave that there. We're going to just Control X, Control V, Control Shift V, and we'll just bring it down here. Let's fill in that black gap there. This one, you. Cool. So I got there in the end. Woo. Okay, so I've got this as a different thing. So here we've got some additional logic, and I've just removing out that out of the way to start with, because our start is looking a little bit different now, because actually we've got a bunch of things we need to think about. Okay, so firstly, it's not start anymore. It's not start. We've got a couple of things. We've got interact with lever as one entry point, and we've got interact with pedestal as another entry point. So we've got two events. So we're now changing our flowchart so that it's more like events than just one starting point. Interact with lever. What does this do? Well, first thing, play animation and sound of activate lever. So that's a process. So we put it in our little box like this. The other thing it should do, unlock door. Okay, so seems straightforward enough so far, right? We've got an idea that this is already happening in a script, so we can kind of blue tick that. Tick. This part, we should just be able to bind it to our door script. So that's probably how we will do that. So that's like a bind thing. Interact with pedestal. Right, so the first thing we need to do is change the color. The first thing that happens when we interact with the pedestal, it no longer just goes door open and all this stuff. When we interact with the pedestal, first thing we need to do is door locked? Question mark. And this goes in a diamond shape like this. Okay, so is the door locked? And we talked a little bit about this last time. There's two options to that statement, isn't there? There's a yes option. Yes, the door is locked. No, the door is not locked. If the door is locked, play locked sound, which is a process. And that's as far as it goes. Nothing else happens. If the door is not locked, do all of this stuff. Let's just grab that. And that goes there. Okay, so we've changed it quite considerably. We've got two starting points now, two possible events. One of them is just a straightforward do this, then do this. This unlock door thing is also a thing we might need to consider as its own event. When we unlock the door, we're literally going to change a Boolean from locked to not locked. When we interact with our pedestal, we're going to check that Boolean. Is it locked or not locked? If it is locked, play the locked sound. Don't do anything else. If it's not locked, then we don't want to interact with the switch anymore. So actually, let's just chop that bit out. Let's move this bit up. I've got this hideous thing going on there. Let's move this bit up. Okay, so the door should open. Let's just cut this out as well. So the door should open. We play opening sound, we stop our opening sound and play door impact sound. Woo! Seems like there's a lot of functionality to write here in 15 minutes, but actually it's pretty straightforward. Let's go back into the game and have a look at how we do that. So firstly, we've done this bit. This is blue tick. The second thing we need to do with our interact with lever is unlock the door. When we interact with our pedestal, what we need to do is check a is door locked thing. If it is, then play a locked sound. Well, we are already playing the locked sound, so we should actually blue tick that. Remember achievements. Okay, so firstly, let's create a property in here that is name equals locked. So this is whether the door is currently locked or not, and we're going to create it as a property. The type of property for this is something you might not have come across before if you're new to coding, and this is called a Boolean. And it's the simplest of all different data types. So a Boolean data type has two possible values, either true or false. And with just that, it's immensely powerful because it's so rigid that it could be really, really helpful to know that a Boolean is either true or false. A string could have loads of different possible combinations, whereas a Boolean can only have 2. And so that's really helpful. Something else I'm going to add. So whilst these properties, we can do this. Actually, we'll stick with this for now. So is the door locked or not? Remember, this door script is attached to the door. If the door is locked, then this is checked. If it's not locked, then it's not checked. And that happens behind the scenes in the game. Do we want our door to be locked to start with? Yes, we do. So we set this property to true in the editor. When the game runs, that property could change. We can make it not locked. We can make it locked again. We can flick between the two. We could make it, locked for different people down the line, when we get a little bit further with our scripting. But yeah, we can turn this property on or off. We can turn it on or off in the editor, and we can turn it on or off in code. So this property is locked, and at the moment it is true. So here in open door, we need to check whether that property is locked. Remember, we're now trying to do this is door locked part of our flowchart. So we're going to go if, which is a new Lua keyword, if self.properties.locked, then, actually let's start with equals true, then play our locked door sound. End. So if that is true, then do that. It actually reads, and it makes a lot more sense to read something like this once you've started coding a little bit. And it's like, oh, thank goodness that actually makes sense. And this is why this is a scripting language, because things like this start to make sense here. Whereas in other languages, it's got all brackets and loads of syntax and random things, ampersands and stuff like that. And you're like, I don't know what that is. It makes a lot of sense in Lua when you write if something equals true, then blah, 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 blah. Notice there's 2 equals here. Now, what's the difference between 1 equals and 2 equals? 1 equals is assigning something. Remember we had this bit here and we were saying we were saying run this function, and then with the handle that will look after that sound, assign it to this variable. So put it in that variable. So if I had 1 equals here, this makes no sense because we're saying if self.properties.locked, make self.properties.locked true. And that doesn't make any sense. We want to check self.properties.locked is equal to true. So the 2 equals signs means, are these the same? Rather than make this thing equal to true. Rather than put true in our shoebox of locked in our variable. So check that they're equal, and if they are, then run the code after the then and before the end. So any code we write in here before that end will only get executed if locked is true. What's quite interesting here is that this code will run regardless up here. Any code up here will run regardless of whether locked is true. This chunk here will only run if locked is true. And then after that end, we'll actually carry on running this code, regardless of whether locked is true or not. So let's uncomment this and let's just see what happens for experiment's sake. See what happens when we run the open door function. So at the moment, the pedestal, we interact with the pedestal and it runs the open door function on the door. We're going to check whether locked is true, and if it is, then we're going to play the locked door sound, and then we're going to carry on running this code here. And let's see how that plays out. Interact. So notice, if you can hear very carefully, it's playing the locked door sound and it's still opening the door. So let's make it only play the locked door sound if it's locked, and if it's not locked, then open the door. And the way we do that is introducing a second, or technically a third keyword, Lua keyword, which is else. If, then, else, let's tab that in, and then end here. So we have an if, which opens up our conditional. And it says, if this condition, after the ifs, before the then, if that is true, if that statement in there is true, then do this. Else, if this condition is not true, it will ignore this code and it will only run what is between the else and the end. So if true, do this. If not true, do this, i.e., is the door locked? If that condition is true, play the locked sound. If that condition is false, open the door, play opening door sound, stop opening sound, and play door impact sound. Let's have a go. Let's try out our logic. Let's see if it's working. So interact with the pedestal. And so no more does the door open. And let's go over here. Let's pull our lever. So that doesn't do anything either. So the last piece of the puzzle. This lever here, when we interact with it, it should unlock this door. In order for that to happen, we need to write a function which will unlock the door. So door script, unlock door. We're declaring our own function again. Like we did with this open door one, we're going to write the name of our own function. So this won't get called by Crayta unless we bind it to something or we call it in our script or something like that. There's no part of Crayta where it will automatically call this function. We need to call it ourselves, and we can do that using the events and the binding and stuff like that. So unlock door. And so we want to call this function, and here we're going to do self.properties.locked equals false. So locked starts as true, and we can even put default equals true here so that we can automatically make whatever we put this door script on default to locked. And then when we run the unlock door function, locked will equal false. Now, how do we run unlock door from this lever? I'm sure you can figure that out, but here we go, just in case you need a hand. On interact, hit this plus new binding here. We're gonna drag the door. Where's the door? Temple door. I'm gonna drag the door into the entity, door script, and then now when we click the down arrow, there's two functions. There's the open door function, which will only work when the door is unlocked. There's the unlock door function, which is the one we just wrote, which will make the door unlocked. So press F5 and let's see what happens. Firstly, we need to check all the conditions of the things we just made. If we just do what we intend it to do, then that might work, but we might have created all these other problems that we just don't know about. So we have to test everything. Does the pedestal work? No, it plays the locked door sound. Okay, let's interact with this switch here. Okay, that's done something, and that looks like it's worked. So now let's go back to the pedestal, and now the door's unlocked. We're making a puzzle game. Yay! We gained entrance. Little bit of tidying up to do here and here. So this is what I mean when don't just test what you've written as if it's supposed to be like that. Remember to go up and try and break it. So we've broken it a little bit because I can switch the lever to activate again and again and again. So one thing I might want to do here is make a property called active. Type is Boolean. Default equals false. So by default, this lever should be in the deactive state. And then I can use our condition here. If self.properties.active, then set the lever to be in the deactive state. And then in the activate part, if self.properties.active, oh, this should be not. Yeah. If not self.properties.active, as in this is a deactivated lever. So this will reverse whatever comes after it. This not. So rather than just doing if this thing is true, let's say this thing is false. If this thing is false, then deactive. Yep. If self.properties.active equals false, then do those things. Otherwise, don't do anything. So let's just see the adjustment I've made there. So what I should have done is I should have said first what I was going to do. And that was to stop the lever continuously being able to be made active. So now when I press it, it works. And let's press it again. It still works. I haven't fixed it. I need to check. I need to also make self.properties.active equal to true once I've activated the lever. So I'm activating the lever by playing this animation, playing an activate sound, and set the active to true. So now active is true. So now when I interact with it multiple times, it will only flick once. And that's because once active is true, this statement is no longer true, which means that this code will no longer run. One of the things I was doing there was I was doing some shorthand. So where we did this, if self.properties.locked is equal to true, I can actually just write if self.properties.locked, because that in itself is either a true or false statement. So I can just use that rather than checking it's equal to true. It's already doing that check, because if that's true, then it's true. Here, I don't actually have to do equal false like this. What I can do, if I want something to be false, I can do if not that. So if self.properties.active is false, if not self.properties.active, that'll be the reverse of false, which is true. So we can do it like that, which is a bit difficult to get your head around at first, but basically, if this thing is false, then same as that. Whereas without the not, if this thing is true, then. Okay, hopefully that makes sense. What else can we do? What else did we run into? Well, we found that when we hit this pedestal multiple times, it kept running the open door function once we want it to keep doing this when it's locked, so that's what we want. But if the door's open, we should only run this once. So let's add another property. The property is open. Type is Boolean again. Default to false. And because we are good, yeah, default to that is false. So when we unlock the door, we don't change that. And in the open door function, we need to firstly here. So when the door is already unlocked, we need to check if the door is open before running the open animation. Because if the door's already open, we don't need to run the open animation again. So if self.properties.open then. But we don't want if it's open, we want if it's not open. If the door is not open, do all of this stuff. And don't forget to set the door to being open. Self.properties.open equals true. So now we're saying if the door is not open, then open the door, do all of the funky sound effects, etc., and say that the door is open. So let's try that. So we're just fixing those bugs. You noticed we had some bugs there. We've gone back in and we're now making it really right. So let's try. Firstly, interact with the pedestal. Okay, so the door's locked and that's fine. Let's interact with the lever. Can't interact with it more than once, which is perfect. Let's interact with the pedestal again. Door opens. Let's try again and again and again. Okay, so we can only interact with the pedestal once. Brilliant. Okay, I think we are pretty close to being done. Yeah, I think that's pretty much it. Some more things that you could do if you were inclined to continue with this would be to use some of the stuff we did last week with playing effects to get like a cool smoky effect appear when the door opens. You could also try adding different switches around the level you could do some kind of combination thing. There's an amazing package called the rune combination package in the community. Let's look for that. Rune combination lock. You could use the rune combination lock. There's some events hooked up already in there. So you could make it so that rather than having this lever, you need to use the rune combination lock. That might be something fun for someone to try. Hopefully this has been a useful and interesting stream about, let's just go back over what we've looked at, because it's been quite a lot. We've looked at, we did a recap of what we did last time. We looked at how we write code, which is instructions that the computer can follow, so that when we as programmers aren't there, we don't have to pull the strings behind the game to make it interesting for our players. Instead, we leave instructions for the computer to make the game fun, to do all the things we want it to do. So code is instructions. Lua is our scripting language, which is our kind of language where we can kind of talk to the computer and the computer can kind of understand. So it's our way of being able to talk to the computer. Computers can't really understand English. It's full of colloquialisms and hand gestures and eye contact and all that sort of stuff. So, but it can understand something as logically structured as Lua. So we have Lua to do that for us. After we talked about recapping, we went ahead and we had a look at our code and we said, hey, there was a bunch of code left over from last time, so we got rid of that. We returned it to the state it was at. Then we looked at making the pedestal open the door, and we did that by writing some code that plays an animation and plays a sound and returns our sound reference. We talked about schedules and how you can use those to delay some code from being run for a certain amount of time using schedule and wait, and give the number of seconds in the wait brackets there. We talked about arguments as well, so things that we can put in between the brackets that will change will affect what each function does, and for what goes in between those brackets, check out the API documentation. So we had schedule, and we said wait 1.2 seconds and then turn the sound off and play some kind of clong sound when the door is fully opened. And that was all going really nicely, and then I threw something at you that was like, hey, what if we don't want just the pedestal to be able to open the door? What if we want other things to be able to open the door? And that's when we looked at the onInteract binding, events in their entirety, and we moved the script to the door instead of the pedestal. We changed the onInteract to open door, and then we started calling the open door function from loads of different things in our game world. At that point, we were like, hey, this is cool. The pedestal's opening the door, but what if we want to lock the door? I introduced this lever. I introduced the concept of conditionals and booleans. So we have these two boolean data here, these two boolean properties. And I said, hey, we can create these booleans and then we can interrogate them using if statements. And we did that a whole bunch. We did it for adding a locked door functionality, and then we also did it for fixing some bugs where the door kept opening whenever I pressed interact and the lever kept switching whenever I pressed interact on the lever. And that is everything we've done today. If you've got any questions, please don't hesitate to get in touch. Head over to the Discord, discord.gg/Crayta. Don't forget, if you haven't subscribed to this channel, to subscribe to the channel, hit like on this video, comment below with anything that you would like to see in future tutorials, in future streams, or anything like that. If anything particularly didn't make sense as well, don't forget to ask below and I will return to that topic next stream. So specific questions would be really, really useful for our recap next week. Yeah, and I look forward to seeing your doors and locked doors in Crayta. Have a good evening.